So if you look at that page of notes, the first thing that you should see is the fact that I said, remember how to FOIL? The same rules are going to apply when we are multiplying binomials that have radicals in them. So if we take a look at the first couple of examples, first times first, that's 15. Outsides would be plus 10 times the square root of 3. The inside minus 3 times the square root of 3. And then the last would be minus 2 times the square root of 3 squared. Now, we can combine like terms. We get 15. The next term is 7 square root of 3. But this last term, remember, the square root of a number squared, the square root and the exponent cancel each other out. So we end up getting minus 2 times 3, which is 6. And then we need to combine our like terms. So 15 minus 6 is 9. So the solution here is 9 plus 7 times the square root of 3. Taking a look at the next one, and on this it's really not showing up well. It's this whole thing squared. So again, the same rules apply. We can say a squared plus 2ab plus b squared. So a squared would be 4 square root of 2 squared. So that's 16 times 2 plus 2ab. So that's 2 times 4, which is 8. And then we multiply that also by square root of 2 times square root of 3, which is square root of 6. And then b squared, which would be square root of 3 squared, which is just 3. So this becomes 32 plus 3, that's 35, plus 8 times the square root of 6. So let's take a look at the last one. Again, we can FOIL. 4 root 5 times 4 root 5 is 16 times 5 minus 12 square root of 10 plus 12 square root of 10 minus 9 times 2. These middle terms cancel. We end up with 80 minus 18, which gives us, is that 62? The example that you just saw is actually, they're called conjugates. It's kind of like this difference of squares. Again, I apologize that my PowerPoint didn't show up quite as well as I would have liked it to. But these conjugates work in the same way. What ends up happening is you get a root b squared minus c root d squared. As we simplify this, it ends up being a squared times b minus c squared times d. We use conjugates in order to rationalize the denominators. Remember when we were doing trig, we weren't allowed to have a square root in the denominator. The last couple of sections, we weren't allowed to do it either. Sometimes our denominator is actually a binomial that has a radical in it. So we will use these conjugates in order to rationalize that. Again, I apologize, the transfer didn't work properly, but taking a look at the next problem. In order to rationalize this denominator, what we are going to do is multiply by the conjugate of that in both numerator and denominator. When we do that, we're actually foiling the numerator, so that's simple enough. 2 times 1 is 2, minus 2 square root of 3, plus square root of 3, minus 3. The denominator is now the conjugate. So if I think of it like a squared times b, that's this whole term. A is 1, b is also 1. So a squared times b is just 1. Minus c squared times d, that's this part. C is understood to be 1, so c squared would just be 1. D is what's under the radical here, and that's 3. So 1 times 3 is 3. Now I can simplify. My numerator, I have 2 minus 3, so that's negative 1. I have negative 2 root 3, positive 2 root 3, so that'll be minus the square root of 3 over, and then in my denominator, 1 minus 3 is 2. I apologize, negative 2. So from here, we can factor a negative 1 out of everything. That becomes 1 plus the square root of 3. And negative 1 times 2. Our negative 1's cancel. And our simplified version of this is 1 plus the square root of 3 over 2. Taking a look at the next one, we're going to go through the same process. I have a binomial containing a radical in the denominator, so I will need to multiply this fraction by the conjugate of the denominator. Lots of you will make this mistake and you'll try to multiply by a conjugate of the numerator and of the denominator. That will not work. Remember that the only time you can multiply a fraction is if you multiply the numerator and the denominator by the same value, because you're always allowed to multiply by 1. So in this case, the conjugate is the square root of 5 plus 1. My denominator, a is 1, so that's 1 squared times 5 is 5. And then I've got 1 squared times 1 is 1. So I have the square root of 5 plus 1 over 4. That's my final solution.